Posso iniziare? Okay, good morning. This time it's our turn to talk about something different. ntopng. What is ntopng? It's an open source application, of course. We are here. You can download the code on GitHub. You'll see the link at the end of the talk. So what is ntopng doing? It is, first of all, a real-time network traffic monitoring application. So it means that it displays you on a web interface what is happening on your network live, okay, no delay. This unless, of course, we are receiving flows coming from a router that are somehow a little bit delayed because by nature they are an average, so they have a certain lifetime. And it is designed for network monitoring and cybersecurity. It means that there are some behavioral checks. So we are not bound to rules. You have seen Surikata, the presentation before. So you see there are some rules in case this happens then. So this is not our case. So we work based on behavior. So it means that if you have a host that is misbehaving, more or less similar to what you have seen before, that suddenly start to send too much traffic with respect to the past, or starting to fire up a new application, so accept connection on a certain port for TLS that was not open before. This is a typical example. So therefore it means that the application simply starts up and learns what is happening on the network. There are some levels of learning. So sometimes it is an immediate learning because you specify some sort of configuration, but usually this is not the case. The case is that the application learns what is happening, and in case something goes wrong, goes different, fires up an alert. This is the idea. And the architecture is actually divided in two parts. Okay, first of all, the packet processing part that is based on more or less PF-ring or lib pickup. So this means that you can run on Windows, Linux, macOS, FreeBSD, whatever. Instead, PF-ring is something that we have co-developed. That is, it's a Linux technology for accelerating packet capture, but not only for that, but also, for instance, for merging traffic for multiple adapters, for distributing traffic. So it's much more than simply RX acceleration. On top of this, there is an open source library that we still maintain at ntop called NDPI. So this is the only open source library that is doing the packet inspection. That for us, it means that we try to understand from the traffic what is the application protocol. So if it's TLS, if that's a generic protocol, or if it's Google mail, that is a very specific protocol. And out of the traffic, we extract the metadata. So for instance, we extract certificate information, and we generate something we call risk. So looking at the traffic, we see if there is something wrong, okay, such as, for instance, an expired certificate, just to give you an idea, and we trigger an alert. On top of this, there is ntopng, because this is the first part that is basically provided by the operating system. ntopng has a C++ engine that is processing packets, that is, in essence, doing traffic analysis, creates internally, okay, the representation of the data, based on the concept of network interfaces, because we can have multiple network interfaces from which the traffic is received. It can be a virtual interface, such as net flow collection, or a physical interface, ETH0. And then we have something we call behavioral checks, where we check flows and host. Flows means that each independent communication, such as, for instance, a TCP connection, is checked. Instead, a host, we take the host as a whole. So in essence, if host is doing a port scan, each individual communication is okay, or more or less okay. But the fact that this host is doing this, in a sequence, in a network, or on a host, it's a problem. So this is called behavioral checks. And on top of this, we trigger alerts, okay, that can be consumed locally or sent elsewhere. This is the fast part. On top of this, we have the Lua interface. Why Lua? Because we like C++, but C++ is something not for everybody, okay? So we need to simplify, for instance, the development of the web interface. So for instance, the REST API is written in Lua, sitting on top of C++. So we have created an API that allows us to avoid typical problems of C++. At the same time, we simplify the way the application is working. So therefore, we use Lua for operations that are not critical, such as the web GUI, or for checking interfaces that are not necessarily real time. So for the SNMP. For SNMP, we fetch the data every 5 minutes and do the checks. So traffic ingestion, as I said, is done in multiple ways. Sometimes it's serial traffic, so packets. Sometimes it is not, it's a flow. And this is handled by the C++ engine. So the C++ engine is doing it efficiently. And then we have other type of ingestions based on events. So something that we don't really control completely, but that are relevant for us. So we have seen Suricata, the presentation before, some minutes ago. This is a typical example of input. Why this? Because as I said at the beginning, we don't have rules. Okay, we don't want to have rules. So we don't want to say if the payload contains this and this and this and this, then, because we don't believe that this is what we should do. Instead, there are wonderful tools such as Suricata that are doing that very well. So therefore, the idea is to combine network monitoring and behavioral analysis with this type of tools. So therefore, indirectly, through tools as Suricata, that is optional. Of course, you don't have to run it with ntopng mandatory. You can have this type of information that can be combined directly by ntopng. Of course, we have firewall logs and syslog. Why this is important? Because we can, for instance, have a look at the information that is not visible from the traffic. So we always play with packets, me and Alfredo, but we understand that packets have limitations, okay? Especially for encryption. So we have seen before rules saying if you're downloading a binary application, that is fine if it's plain text. But if TLS, you will never see that happen, okay? So you have to use things like rules on top of this, but they are just guesses. So instead, if through syslog or other means, we know that. So for example, we see an attack on WordPress saying that this host is trying to guess the password of the administrator user. This is much relevant information. And from the network standpoint, it looks simply nice. Everything is okay. The problem is that from the application. That's why we believe in network, but at the same time, we need to have some other information that is injected into the application. And of course, we have historical data. We use a database called ClickHouse, so we can put billions of records. Everything is working, very fast. This is also an open source database. And for time series, we use round-robin database or InfluxDB. And as I said before, we have checks that are divided in two parts. C++ for efficiency, so the fast part, in essence, where you have to process traffic in line, such as when you have a packet, an incoming packet, you have to check if this packet belonging to a flow, it's relevant. And then we have other type of checks that are not so real-time. So for a check on an SNMP interface that need to be easy to be developed, but at the same time that don't need to be fast, because as I said, if we poll SNMP every 5 minutes, we have plenty of time for doing that. And of course, we have notification that we send out. So for example, we trigger a shell script, a webhook, syslog, email, Telegram, usual things. Nothing new here. Okay, let's now start the talk after this introduction of ntopng. The problem is the following. So we have added over 150 checks, behavioral checks on the traffic. But there is always somebody that comes and says, I want to do something different. How can we support these people? How can we enable non-programmers, or let's say people that used to use Python, shell script, this type of programming language, or that don't want to learn the internals of our application? How can we do that? And many times this happens when you are in a rush. So there is an attack. There is something happening on your network that you want to check. And we have two levels of the problem. First of all, we have to extend the behavioral checks in order to have some behavioral detection in a different way. And in the second part that Alfredo will describe later, so how can we use ntopng as a data lake from languages such as Python, for instance, that is very popular, so that you can use ntopng as a source of data for your own application. Of course, you have time series. As I said, for instance, we save data in InfluxDB if you want. So therefore, you can use Grafana for creating your own dashboard. But these are simple dashboards. So if we want to do something more complicated, if we want to go beyond that, in addition to that, how can we do that? So this is the idea today. So we like C++. C++ is super efficient. We like it. Okay, we are used to play with it since many years. But we understand that it's not what everybody wants. Okay, we need something easier. And we would like to understand also how it was possible to develop checks in minutes for people who are saying, okay, if I see this specific certificate or if I see this specific behavior, then there is a problem. something very peculiar to an organization. So not general for everybody, but for specific people. So for instance, how do I trigger an alert if there is traffic, TLS traffic between host A and B? So for instance, a printer should not make any TLS traffic, just to make an example. So if this happens, and how can it trigger an alert? Another problem is the following. If I have a certificate signed by a certain organization, or for instance, if I have a BitTorrent connection that is going above 1 gigabit, or notify me if there is a Zoom call with bad quality. Things like this. Things like, very, very peculiar, very specific checks that people want to do. Maybe on an autonomous system and not on another, or on an actor and not on another. So things that are not general that we can implement for everybody. How can we do that? So let me talk how it works in ntopng internally. Let's have a look at the flow, also our communication. So ntopng creates a data structure inside itself as soon as we see the first bucket of the flow. So we see IP source, IP destination, source port to destination, protocol, VLAN, whatever. Okay? And then this is the first event that is relevant for us. And then, as I said, everything sits on top of NDPI, so the yellow part. So we have another event when the application protocol is detected. Actually, this one is divided in two parts. First of all, as soon as the main protocol is detected, such as TLS, okay, and then we can refine this information with metadata, saying, okay, this is TLS that is going to Google Mail, and not Google Search or Google something else, okay? So second event, NDPI. And then we have, for long-standing flows, some periodic activities. So in essence, every minute, we do something different, something like, I want to trigger, an action. And then at the end, the flow end notification, so as soon as the flow is over. So what we wanted to do, we wanted to create a low API that allows people to create simple checks that are efficient enough for most people, because not everybody needs 100 gigabit, but many people have 1 gigabit networks or 2 5 gigabit networks. So they need some sort of efficiency, but they are not super extreme. So let's say use Lua for prototyping a check for some people who need speed, or use Lua for people who have, let's say, an industrial network or a network that is running at 1 gigabit or 2. So in essence, we have created an API that allows from Lua to see internally in ntopng properties of the flow. For instance, the number of bytes, multicast, layer 7 information, this type of things. And the API calls are very small. So in essence, we don't want the application to be inefficient simply because we download to Lua the representation of the host, the representation of the flow. Well, simply the method that we are interested in. So in the left side, you will see the C++ code, how it implements the stuff. On the right side, you will see an example of the Lua code. So in this case, just to give you an idea of how it works, so whenever there is one of the events, so for instance, we have to check the flow because NDPI is over, so the protocol has been detected. So if you want to block, let's say, Google Mail, okay, so what you need to do is to execute a Lua check after this happened. So in essence, inside the C++ code, we have put the call to the Lua VM that executes a script. Okay, a script that can be applied to many flows, not just for one. So this is where this happens, and this is an example of a check. So very simple example. If you have a flow that is either TLS or quick started from host 192.68.178 to 1.1, and if it's TLS, and if the protocol issue is, so a very simple check that, for instance, a friend of mine has asked it because he's monitoring IoT networks, and they have found a vulnerability on a specific type of rule, and the client was a specific device. So something that is not general. Okay, so this is the way it works. Very simple to write. The problem is the following, that the overhead introduced, this is a very slow Intel i3, so just to give you an idea of the super worst case, it's 30 microseconds for everything, okay, in average. Whereas with C++, we can do it in 1 microsecond. Now, you say, this is bad. In a way, it is bad, I agree, because we are 30 times lower. But you have to think, first of all, on 1 gigabit networks, that this is not the problem. Also, you have to think that most of these checks are asynchronous. This is one of the few ones that are synchronous. So in essence, as soon as the protocol has been detected, we call this method. But it is not while the packets are coming. So in essence, we have another thread that is calling this while the traffic is coming. But we don't stop the execution tree. So in essence, just to make it short, so if you take this overhead that you have introduced and you sum to everything and you stay below certain boundaries, so if you want for every minute to execute flow checks on all the flows, you're good. Okay? And of course, we trigger an alert. And the result of the alert is a notification on the GUI that can be sent, for instance, through Microsoft Teams, just to give you an idea. Or we can trigger a shell script for something, or can send an alert to my friend on Telegram. So this is the way it works.
Okay, now I have this. Okay, so we have seen how to extend the ntopng engine with Lua scripts to access traffic information and use those information to check the traffic and trigger alerts, for instance. Now, we recently released also a Python package that you can install with pip install ntopng that allows you to, you can use it as a library to create a Python script which is able to access traffic information in ntopng. And this happens through the REST API. This means that you can run your script even on a remote location. For example, you can access live data in ntopng. In this case, we are importing the ntopng class. We are connecting to ntopng using the ntopng class. We get an instance of an interface in ntopng, for instance, ETH0. And we use this method to get all the hosts which are active in my network with all the metadata. And there are plenty of methods in this class or in other class in this library that allows you to get traffic information. So you can get alerts, flows, hosts, whatever. And you can also get historical data. So same way, so you connect to ntopng, you get an interface. From this interface, you get an instance of the historical class, and you can run queries in the database. For instance, you can get alert statistics from this time to this time, for instance, for the last 24 hours, and just print all the alerts that you have. Now, those are two examples of querying the engine to get the data. Of course, we have seen that ntopng is able to, when a check or an external event detects something, an event, we can trigger an alert. And we have seen that ntopng supports several endpoints, so we can send this alert using email, a messaging system like Telegram, Slack. We can run a shell script. We can call a webhook. So we can run a shell script, for instance, and this script can be a Python script. So let's try to put all the pieces together. So we receive an event which is generated by an internal check or an external check. This event can call a Python script. This Python script can get information from the alert itself or can query the engine through this API that we created to get more data, to fetch more data and augment the alert information. And this can have some logic and trigger some action. So you can write your actions here to react to this event. In order to implement this, what you have to do in ntopng is, first of all, you have to enable the check that you want to use to analyze the traffic. For instance, in this case, we are using a custom check that the user creates in Lua, as Luca showed you before. Then, if you want to write your Python script that reacts to this event, you have to write an alert handler, which is a script that you place under ntopng script shell. And in this case, this is a simple script which is just getting as in the standard input the traffic information, the metadata. And for instance, if the alert type is our user script, I want to do something. In this case, I'm just logging the IP address related to the host that triggered the alert, and a message from our custom script. Then you have to go inside ntopng, you go under notifications, you set that you want to send alerts to the shell script. Here you have all the options like email, whatever, and you select your handler. And then you specify for your handler that you want to receive just critical alerts, so you specify the severity. you specify the category that you want to, of alerts that you want to handle, for in this case cybersecurity, and the entity. In this case, I want to handle alerts about hosts. And then we can extend our handler. We have seen how to print just the alert information, but we can, again, we can use our Python library ntopng to access more information about the host. So we receive this alert, which has been triggered on a specific host in our network. For instance, this host has been infected by a malware, is generating unexpected traffic, whatever. We want to get more information about this host to build a report, for instance. In fact, in our library, we also have the ability to generate a report, or you can generate your own report using the API that we have. So we build this report and send an email. So this is a simple script that you can use. It's a few lines of code to handle alerts and generate reports and get, for instance, an email on your mobile phone with the alert. So this is the big picture of the example that we are seeing right now. So we have defined a user script that triggers an alert, or we receive, again, events from any other source or internal checks. We are calling our script, which is getting more information from the engine to build a report and send this report by mail. So the result is this. So the system is checking your traffic, is building a report when something happens, and will send you an email with a report of the traffic for the host with the top alerts sorted by severity or by count, the top contacts for the host, the chart of the traffic generated by the host, where you can add more, like the top applications used by the host, etc. Do you want to wrap up? Oh, okay. So we have seen that with ntopng you can collect traffic information from traffic, flows, events from Suricata, for instance, etc. And when we started with actually Luca started with ntop, then we moved to ntopng. It was mainly a traffic monitoring tool. Today is also a cybersecurity tool, able to do behavioral checks, not just for providing visibility, but also providing cybersecurity monitoring. You are now able to extend this engine both with Lua scripts integrated in ntopng, or even with C++ plugins, let's say checks, if you need to scale with the performance. Or you can use our Python library to write Python tools that can run externally, even on remote boxes, to access traffic information in the ntopng engine, and build, for instance, a PDF, as we have seen, with reporting what's going on in your network. Of course, all the code is available on GitHub, so if you want to contribute, you are welcome. Especially now, you don't have excuses. We have a lot of libraries, scripting languages for interacting with the engine. So, something else to add?
No, the only thing I want to say is that this is an efficient way from a point of view to do network monitoring and cybersecurity, and at the same time to extract the information in a way that does not interfere with the main engine. So that allows, I believe, most of people sitting in this room to do whatever they like, to create a monitoring tool that is tailored for their own needs. And as Alfredo said, it is open source. That's all. Thank you very much. Any question?
Any question?
Wait.
It's just a simple question. How does it compare with CN tools? It looks like it does everything CN could do. CN tools. Yeah.
I don't know the tools.
No problem.
I am not familiar with them. Any other question?
The scripts can be compiled to be more performant, or do you not have this task in your on your develop timeline to compile script to have more performance? Lua script or like CCC. We saw that CCC script take 1 milliseconds, but the Lua script take 30 milliseconds. Microsensor. Okay. Okay. Okay.
Yes, of course, you can compile them, but you have to code it in C++ at the moment. So we use Lua just-in-time compiler, the one seen before, but by stamp switch. But it is not available everywhere, for instance, on ARM, and we want to support Raspberries. So yes, it is possible, but again, these are microseconds, not milliseconds. So 1 million of them per second. Any questions? Somebody else?
Hi, thank you. Do you have some figures about performance you are able to achieve on typical server, about flow per second? Some figure to share and on the Lua scripting, and also some example on Python, which should be less efficient?
Okay, when you process packets with ntopng itself, we are able to process like a few gigabits per second, depending on the drivers you use, how you tune ntopng, let's say, to scale the performance. You can get 10 gigabits, for instance, but more or less we range from a few gigabits to 10 gigabits in ntopng itself. You can use it in combination with our probes, which is mprobe, or we have other probes like CentOS. In that case, you can scale with the performance up to 100 gigabits per second. But the architecture changes a bit.
Yeah, it's 100 gigabit and plus.
Yeah, as of the checks, it depends on the checks that you enable, of course.
Okay, I think we are running out of time. Many thanks for being here. Now, close it up.